We're going to get started with our webinar today, the 3 time metrics of token economics. And I'd like to introduce our 3 speakers and moderator. Our moderator today is Floyd Christofferson, who's our VP of Product Marketing, Kurt Kukine, who is our Senior Director of AI Product Marketing, and Ryan Chikantis, who is our AI Product Lead. Floyd, take it away.
Thanks, Trip, and thank you and welcome everybody to the webinar. One of the things that we want to really cover today is, unless you've lived under a rock, the pervasive aspect of AI is permeating the industry, storage industry, enterprises, not only just the hyperscalers and the big accesses, but as enterprises are trying to figure out how do we actually operationalize AI, how do we use it, what is the ROI? And so a lot of this focuses on producing tokens faster, more cheaply. We've seen articles in the trade press about token economics, about token value maxing and token maxing. But the problem is that the idea is not just a simple, how do you get the tokens faster? Everybody is working to reduce the cost of generating tokens, but how much time and money are consumed before an organization can generate a first useful token? So today we're going to introduce a concept called, that we call the 3 time metrics of token economics. It's really looking at token economics from end to end. And as Trip introduced Ryan and Kurt, I'm joined by 2 men that are experts in this field. Ryan, who runs our product marketing or product management AI practice and has a long experience in AI workflows and workloads, and Kurt, who runs the product marketing for AI and also comes with a long background. So let me set this up. This is going to be, we're attempting to make this more educational. This is not meant to be a product pitch, although it's very clear that Hammerspace has an offering and a value proposition to bring to this. But what we really want to do is discuss the practical problems across what we're terming these 3 stages: this time to first token, time to very first token, and then time to first token, and then time per token. And so how we actually bridge all of these. And so let me just open it up to the group and maybe ask you guys, it's like, what is the problem and what is the initial problem that we're facing with even just this time to first token? What is the problem and what does the landscape look like? Ryan, let me start with you, just kind of from an industry standpoint.
Sure. And thanks, Floyd. Thanks for the introduction, and thanks everybody for joining. So really what it comes down to, very first token is kind of a new term, right? We're going to try to go through what we think of getting to that very first token. And to me, it's really going from a conceptual idea to productionizing a workload that may have some AI use cases or some type of agentic use cases, right? In my past role at one of the large cloud vendors, my focus was on helping customers build their first cloud native applications. In the last 5 years, obviously, a lot of that had to do with AI, LLM, agentic type workloads. And after we defined what they want to do, figure out what business problem they want to solve, why they think they needed to solve it, the first question I was come up with was, what data do you have to actually have to address the questions that the model might want to ask or that the agent might want to ask on? And 8 times out of 10, you get blank stares. I know I have a problem. I think I have data to do it, but I'm not sure where it lives, who owns it, is it secure, is it compliant, does it have PII, so on and so forth. So even from a POC perspective, a proof of concept or an MVP, we're just trying to prove viability before you invest the time and the resources to get to a 1.0, 2.0, et cetera. You're trying to really say, do I have data enough to answer these questions, first of all, and are the right people going to see it? And that's a hard problem. What's even harder and where the pressure comes in to get to that very first token is once you prove it in a proof of concept, now your management chain, your business leaders, they get excited about it and they say, okay, when can we get everybody access to this, right? And so you're thinking about how hard it was to get from just a small data set into a proof of concept to your full data environment and all the various silos, architectures, locations, types, structures, et cetera, that data lives in, it just becomes exponential. And again, you're getting pressure from the top to say, where's the ROI on this? How are we going to start seeing that? And so that's really, from a business perspective, that I saw that every month with every customer I work with. Thinking a problem is one thing, solving it and making sure the data is ready for it is a totally different thing. And that's really where some of the Hammerspace tools can come and help.
And Kurt, I mean, why should organizations treat this elapsed time as an economic issue rather than just a scheduling or an implementation issue?
Yeah, I think this issue becomes actually really strategic because of the realities of even, the market today, being able to get the right resources, whether it's people resources or even hardware, right? We know we've got a crisis around the availability of memory and SSDs. And so actually getting hardware provision, new hardware, has months, even years lead time these days. And so if you're relying on, something completely new, a new system, especially around your data, which is going to, require a large number of SSDs, your wait time, if it's not already in the queue today, is now, 18 months out. And you've got all of these delays that are actually delaying, right, your ability to deploy an AI application and just get to work on it. And so, if there is a way, right, to leverage what you already have in place, that is going to be a strategic advantage for an organization. They can get started today versus someone who's sitting on the sidelines, waiting to implement, waiting for their hardware to arrive, and then, starting whatever time that is later in the future, versus why not get started today with resources you have today, and get moving.
So Ryan, this also goes back to kind of what you were saying, where a controlled environment in a POC is very different than an operational environment. And, so it's, and again, I didn't mention this earlier, but if you do have questions, please put them in the chat, and then we'll answer them as we can. But, talk about sort of what you've seen in your travels, with customers as well in, what happens in a POC that's different than in an operational environment? Because we're really talking about the whole end to end, right? The 3 clocks, the whole concept here is it's not just generating a token, it's an operational flow, right?
Exactly. And the risk behind a proof of concept in a controlled environment is much lower also. So the pressure to get ROI and get to that very first token as fast as possible isn't really there. I just want to see if this thing can work, right? We haven't really, if we're using the cloud, for instance, I'm renting GPUs. I don't need to set up the infrastructure to power and cool and operate those. Plus, I don't have to wait for them to show up in my data center. They are there for me on demand. I can spin them up and spin them down as much as I want and run a proof of concept against that really quickly, right? I know what data I want. I have a core set of questions I want to ask of it. I want to see if this agent can actually interact with this MCP server, et cetera. And doing that in a proof of concept with a small data set, targeted data set, you can do in a day. People with Claude and other tools, somebody who's not even an engineer can spin up a proof of concept and run through these things really quickly. But again, they're not concerned about compliance. They're not concerned about how active that data is. They're not concerned about how big it is. They're not concerned about how many copies they're making because it's centralized. Once I try to say and get to my management and say, this works, I want to roll this out, I want to go from proof of concept to MVP. Now the question is, where does all the data live that's going to provide true value based on what I want to do versus this limited data set? Do I have to copy it? Do I know where it is? Is it in a cloud? Is it in NAS? Is it structured? Is it unstructured? How much of that do I really need to continue to show that we want to invest and spend on this, and how quickly can I get to there? So all those challenges from copy to visibility to compliance, they're stalls, right? They are barriers to entry, and they get you from very excited to that kind of trough of disillusionment, if you're familiar with that old Gartner term, that, this looks great on purpose and on premise, and your POC worked great, but we can't make it run yet because we can't get data to this thing to make it actually work.
So to both of you, I mean, from your experience and what you've seen, do projects stall? I mean, I've seen stuff in the trade press where up to 70% of enterprise AI projects stall or don't even get off the ground. Is that your experience?
I think, to kind of Ryan's point there, he touched on all of these different areas that can influence that stall, right? Whether security team comes in and says, hey, stop. We don't want to be sending our data to the cloud. We don't know what you're doing with this data. There's a barrier right there. Or the infrastructure team saying, hey, we don't have GPUs provisioned, whether they're on-prem or in the cloud. We're not ready to start today. Or, yes, we had 8 GPUs for a POC, but now we anticipate needing 20, 200, right? Being able to scale that way is another, right, barrier to something that is just operationalized. And so I think all along the line, you can anticipate challenges coming in. At the same time, right, I think there are solutions out there, including Hammerspace, which help you address those proactively rather than reactively.
So this is what we're calling, making things AI ready, or getting, making your environment AI ready. Is that right?
That's exactly right. Yeah. Exactly. So knowing that data is actually prepared and exposed and accessible, and organized and ready to flow into your AI factory, I think is, being comfortable with that, understanding that that's ready to go, means that you're proactively addressing a lot of these potential barriers.
So isn't also a lot of that upfront cost where a vendor might say, sure, no problem, you want to do an AI project, let's just build out a whole new infrastructure, copy all your data into that, and off you go. Life's good. But doesn't that also create not only the limitations on available hardware, but also just the logistics and the compliance and exposure to do that copy? Is that been the kind of one of the other traditional stumbling blocks for enterprises?
Yeah, I mean, 100%, right? One of the challenges, especially in larger, more established enterprises, they've gone through acquisitions, they've acquired different things. Nobody has one vendor in their data center, right? Everybody has multiple vendors of arrays and NAS devices and clouds, et cetera. And so if you're just going to add another one, you're just adding another silo. And the infrastructure is one thing, copy is one thing, but what about the active applications and users that are using that old storage that now you're copying off? Now you need to manage those other applications to get them onto the new storage, because it's active data set. They're not going to be, static systems that your AI system needs to use. So just plugging in another faster, shinier device doesn't solve the core problem of you don't really know where your data is, and you don't want to copy it all over a bunch of different places to have duplicate information. So it is definitely a selling point of getting something bigger and shinier and faster, but it doesn't solve the sprawl and the silo problems that is one of the barriers to that very first token.
And this is also,
I think that sprawl and silo problem is, really unique to unstructured data, right? So for a long time, we've had actually the structured data problem, and AI, where it's doing analytics or BI against structured data, that problem is kind of solved for people, right? And you've got things like Databricks and Snowflake that do an excellent job of facilitating that and getting folks started very quickly with pre-canned operations and things like that against the structured data. The challenge here that's coming in is now we're trying to do the same thing against unstructured data that is all over the place, right? Whether it's data coming in from external sources, internal sources that are PowerPoints or PDFs just everywhere, but also hold that key insight to being able to move your business forward in a strategic way, right? This isn't just numbers in a column. These are now documents that need to be ripped apart and vectorized and turned into AI consumable information. And so this is fundamentally a leap for organizations to do versus, the stuff that was always kept in databases. You've got database administrators who have been doing this for years and years and years, where this is a whole new talent set, right? These are data scientists that you're having to apply to a problem. And if you're doing all of this manually, right, you're got expensive data scientist time doing manual operations to pull apart all of these documents, get them all organized, get them all cleansed, get them into the right environment before you're even generating a token, right? And so the approach to short circuit that is to automate all that. And by automating all of that, you can reduce your reliance on the amount of talent that you need, human talent working against it, and speed up just the ability to land AI-ready data by a whole order of magnitude. We're talking about cutting potentially years, right? If you're not having to deploy a net new system, or even if you have the system today, months of organization down into even hours or just a couple of days.
Yeah, I mean, I also think because the unstructured data, it's PowerPoints and the kind of business documents is one thing, but manufacturing, production lines, quality control of manufacturing, drug discovery, where they're generating live data. I mean, it's one thing, like you said, Ryan, when it's in a POC, you've
right.
curated a data set and you've put it in there. But the promise of AI to, for example, increase, discovery of faults in a manufacturing pipeline, or, accelerate, but that's got to deal with data that is constantly churning and live. So
Correct.
You can't necessarily copy that out and still maintain that immediacy that the promise of AI brings, right?
That's correct. And it goes back to what Kurt was talking about, whether it's a person having to do it manually or you have these batch jobs that run, at whatever period of time, you can guarantee that your agent or your model that needs most up to date to be as most effective as it possibly can is going to be behind. There's no other way around that, right? If you need to copy things, you need to run a batch job once a week, you're a week behind for your agent and for your workload. So getting all that data, the live data sets, up to date in a single place that your agent doesn't need to change and there's nobody behind the scenes copying things, that's a huge benefit to keeping the value going.
Sure. So how does...
And I think that's a great point in terms of, right, the fact that this is live data, right? We need data currency. So yes, the rush to very first token is essential, but I think it also speaks to, right, the ongoing nature of, okay, yes, so now we've gotten that very first token. How do we also keep incorporating current data and feeding that into the AI factory on an ongoing basis?
Okay, cool. So talk just briefly, again, we're not going to go into a deep product pitch here, but talk a little bit briefly about, okay, we've just talked about the problem. I think everybody's aware of that. Mm-hmm. What's the solution? Ryan, do you want to start?
Well, I mean, that's really where the core Hammerspace global namespace, our global data platform, comes in, is the ability to stretch across devices, whether they're on-premise SAN, NAS, or in a various public cloud, and the ability to bring all those together and show them under one global namespace. So your end user applications or your research scientists or your agents themselves can look at a massive file system that looks like a file system to them. I can access it over NFS v3, NFS v4, right? But it's all the underlying silos combined into one space. So whether it's sitting on a Dell or a NetApp or an AWS, to the end user, they have no idea where that sits. And so that's the first step of, I don't need to copy, I don't need to migrate, I don't need to use new stuff and copy into that new stuff. I can use what I have where it lives today and expose it in a new way that makes it really simple for me to identify it, to catalog it, and to access it for my AI tools.
So just to be clear, so on the slide, we use the term assimilate. And so that means using the data in place, right? But what about other users that are also using that data, especially if it's coming out hot out of an instrument or out of a production line? So, the global namespace means what in that sense?
So it just means, a common share. So let's take a look at, if it looks like your D drive, right, from a Windows user, or if it looks like a mount from a Linux user, if whatever tool is generating the data is writing to that share, you get to see that data as it shows up, just as you would on your own local hard drive, right, your own local directory, on your own local mount. And so now you get a point where the data generation, whether it's an application or people sleep on how much data LLMs and Gen AI are generating themselves, right? The outputs and all the things that they are doing, that is generating data, not just using data. So where we can put that into a place where both the applications, the researcher, and the tools can all look at one spot, right? It just looks like a file system to them. It makes it so much easier to keep that data live and up to date, again, without that copy or without that batch job.
Sure. So, and again, to be clear, you could have your users or your instruments, accessing and seeing that share. But now over here, you've got your agents or your inference engines looking at that same data, correct? And that's not interrupting each other?
Nope, that is actually correct.
So reaching that first productive result is important, but as Ryan pointed out, getting there once does not mean the organization stays ready, which kind of brings us to our second clock here. And that is the time to first token. So Ryan, this is a term that, everybody knows. Time to very first token, nobody is really talking about that. We talk about that
Right.
because we're looking at the big picture. But talk to us a little bit about what time to first token actually means.
So that really comes down to expanding on that dynamic workload, right? Again, the proof of concept, I'm going to zip up a bunch of files, put them somewhere, use them, prove it out, perfect, right? But let's look at a real active use case here. Say you're in support. We've all called support. We've all probably gone in with support organizations. They are getting calls every day. Large support enterprise operations are getting support calls every single day, and they are generating knowledge bases. They're generating updates. They're generating different outcomes and diagnosis tools and so on. Most support organizations today have some sort of AI tool that they use. When they're talking to their customer, they're chatting in the background with some chatbot or some other AI tool to figure out, has this been seen before? What are some diagnosis steps? What are some fixes I can suggest to this customer to not have to escalate to backline support, or hopefully not have to get back to engineering? I can handle this as frontline support. So that very first token, you dump in that first set of knowledge bases, you're going to see everything at that particular point in time. If you're not moving the next days, hours, minutes worth of knowledge bases and KB articles into that agent, then your chatbot is behind. And you might waste time with your backline engineers, with your customers, or with your actual engineers to solve a problem that was solved 3 days ago, but you don't know about it because it wasn't put back into the system that you're using. And again, that comes to the back-end batching. It comes to manual operations. The dynamic needs of an agent is only as good as the data coming in. And as the staler that agent gets, the worse it gets, and the less benefits our customers get from it, and the less impactful the results are for what you're trying to do for your end case. What in this particular case, you're not able to support your customers as effectively as you could be if you have live real-time data coming into your agent.
Right. And so, Kurt, from a business standpoint, then, if you're waiting for data, then we're not just talking about the performance of an individual, architecture. We're talking about, the stall that occurs waiting for that data to actually be orchestrated into the right place, correct?
Yeah, and I think that's directly impact to your customers, whether that customer is, somebody on the support side that's then on the phone with an actual end user, or even end users themselves. Right. And so I think this speaks to the key word here, right, is dynamic, the dynamic environment, right? AI is not a one-shot thing, whether from we supply a data set to the chatbot, right? Or, right, we're in an environment where this is constantly changing. Which chatbot you actually want to use, which LLM is advancing quicker, it's changing on a daily basis, not just weekly or monthly, right? And so to be able to have an environment that allows you to plug in, different models and utilize the same foundation from something that is flexible enough to address each of those models without breaking, right? One of the things that is a challenge if your entire data preparation environment has been built on bespoke, right, and hand-coded transactions, is that you bring in a new application and a lot of those things have to be rewritten. Now, if you have an environment that's utilizing things like MCP or other stable APIs, right, you've got a way to plug different LLMs into that same data foundation so that you can dynamically shift your applications as needed. And the applications, we can't anticipate today all the different applications that we're going to use. People are coming up with new ideas all the time on the AI side. And so having that dynamic data foundation that has data currency, but then also out of the front end has this stable set of commands that the LLM can refer to is essential.
So, Ryan, I mean, this is an important point. We often think about, especially, in the early stages of an AI journey for a company, they're thinking about one thing, but we're really talking about potentially multiple pipelines that develop. And so it's, you basically go through this with each new AI use case that you come up with, right?
Exactly. And with that becomes, the challenge of, I need to show ROI. I need to get my time to first token as low as I possibly can get it. And I don't really care what my application or my data is. I'm going to give it the fastest storage I can possibly find and get it running as fast as I possibly can, regardless of what that data and what that agent actually needs, because I'm being driven by this time to first token and I need to make it as fast as possible, right? And that's really, it's not efficient because you could be storing massive amounts of data on super expensive storage that doesn't really need that or doesn't get access as fast as possible. And so without having the ability to move things around from an automated perspective with awareness of what's going on, you're back to the same problem that we talked about before. Is now the data is really close and really fast, but now I'm manually tiering it. I'm copying things off. I'm moving things somewhere else because it's too expensive and I don't have capacity to keep it all in that super expensive storage. And it's not worth it because this agent doesn't need it. And now I'm doing some manual stuff again. So having awareness of not only the agent and what it's doing, but individual SLAs for those agents is important too. But being able to control those at a workload by workload, agent by agent, LLM perspective is really difficult and takes a lot of time and manual effort.
So, I mean, it sounds to me like we've got two economic problems at least. One is if your option is you have to create a bespoke net new environment, very high performance, very expensive storage, especially now with the SSD crisis. We've seen, the price of high performance storage skyrocket. But what you just outlined as well was another one, which is the operational expense. I mean, IT environments traditionally for the last 40 years have been dealing with siloed data. Doesn't this bring it to an even, a fever pitch where if you're having to stage things to get the data AI ready and you've got this ticking clock of expensive GPUs waiting for that data, that adds cost and impacts the ROI of the project as well, right?
100%. And again, trying to minimize expensive people, right? Research scientists and LLMs and all the tools to run it, that's expensive. You're using expensive storage that might not be needed. That's a wasted expense. And again, how do we streamline that? And from our perspective, it's our objectives, right? It's how do I know where things are, what tier they're on, because of our namespace can support multiple different tiers of storage from high speed NVMe to S3 buckets that are super slow, anywhere in between, with the ability to control where data lives, when it gets upgraded or moved to a faster tier, or when it gets downgraded and moved by a slower tier that's more cost effective. we have the ability to help automate that and streamline that so that person who's expensive and that hardware that's expensive can be put in the right place, not manual effort of identifying and copying and moving data up.
Yeah,
and I think this speaks to kind of the complexity of the problem here as we bring AI into production, right? Historically, the real challenge, especially in training these models, has really been capacity and performance. We needed a lot of capacity with a huge amount of throughput, and we would just batch jobs and send that, into an LLM to train, and that, kind of workflow has now been developed for very well, right? With a parallel file system and all of those things. But this inference world, this agentic world, now brings in a huge level of complexity, but also, all sorts of different economic challenges because the workflow is so different and so dynamic and so, concurrent. And so I think, Ryan spoke to the fact that you have to bring in tiering into this. But at the same time, right, as soon as you're talking about tiering, you're introducing potentially latencies. How do you make sure you solve for a low latency, outcome so that your end users aren't waiting on that data, aren't waiting on that response, and you're still optimized based on cost for each tier of storage, how warm each of the data is.
So let's unpack that a little bit. In the previous segment, you were talking about, with structured data, that's kind of done because it's all within a structured environment. But Ryan, you mentioned the term objectives, which is, let's unpack what that means from a Hammerspace perspective, and how that drives orchestration to essentially create what looks like structure, what is structure out of an unstructured environment.
Right. So our objectives are our view of how we determine where and when to place a specific piece of data based on input from the end users and the administrators. So for instance, we could say, I want to make sure that this data is always in a United States data center. It cannot leave the United States for various reasons. Regardless of where the tiers are, right? We could have a global namespace that is using S3 bucket in Europe. We know where that S3 bucket is under our namespace. We know not to place data there because it should be sovereign to this specific country or use case. Same for performance, right? If you have NVMe storage inside your servers, if that's part of our global namespace, we can specifically place and keep data on that really fast drive that's really close to the GPU until you don't need it, and then we'll push it back to a SAN device or, again, a cloud device, right, as it goes through. So objectives are our way to make sure that we are proactively placing the data in the right place based on what your business needs are for that particular type or piece of data.
And to be clear, when this data is moving around, whether it's between silos on-prem, across sites, to cloud or back, wherever your GPUs may be, I mean, this is not interrupting access to day-to-day users, other users of that data, correct?
Correct. It still looks like a file in that share. The end user should have no idea, other than maybe if it's on super slow disk, you might see a little slower open that file. But other than that, it looks like a file and share just like anything else.
And that's where the objectives, as opposed to just calling it a policy, it's an objective, which is like a declarative business rule for that data, correct?
Correct.
So the second clock is really about then repeatedly putting the right data in the position. And so as we move down the pipeline, the third is really then about what happens after, right? So once the workload is running, Ryan, what prevents expensive AI infrastructure from remaining consistently productive then? I mean, we've kind of talked about it, but yeah, let's dig a little deeper into that.
I think a lot of it comes down to just waiting for I/O, right? You make a request for this file, and if it's sitting out somewhere, maybe it's in the cloud, or maybe it's across the world, the GPU is just waiting. It's waiting for the file to come in. And there was a VentureBeat survey done, 100 something customers. 83% of those said their GPU utilization is 50% or less. So think about all the clamor of, I need GPUs, I need the power, I need to cool these things, I need to get them out there. But what they have already today is only 50% utilized. Why is that? Why don't we increase the utilization of those GPUs versus just throwing more hardware at the problem? Throwing more hardware problem is good for the hardware vendors, but it's not good for us as the end user. So how can we make sure that that GPU is fed as fast as possible? And GPUs, they don't move, right? They are there in the data center, unlike a bit or a virtual machine. They can't move. They are stuck where they are. So the really only option to maximize that is bring data as close to that GPU as possible. It's the GPU gravity versus the data gravity that we've all probably heard over the past 5 or 15 years, right? And so it's changing the dynamics that the GPU is static, it's there, it's expensive. We need to push data as fast as we can to it. And that's really where our objectives comes in, and what we call tier 0, which is taking advantage of in-server NVMe disks as part of our global namespace. And now it is sitting right in the same machine as the GPU. So you're getting PCI speeds from tier 0 into the GPU through the objectives placement, putting it there, making sure it stays there until you're done with it. And then because NVMe storage is limited, right? You don't have infinite capacity inside those disks or inside those servers. Once you're done, move it off to a cheaper tier and bring it back when you need it to keep those GPUs fed as fast as possible. So you're getting the maximum return from that massive investment.
So, I mean, again, if you look at the big picture end to end, often what you'll see in the industry is, I mean, you touched on it, Ryan, an infrastructure approach. It's like throw more gear at it, build a dedicated, storage pod for this, or, beef up the number of GPUs, but that's an infrastructure centric point of view. So, I mean, economically, Kurt, and from a actual adoption standpoint, we're running into the same thing, that it really needs to be data centric, right?
It does. And having a data plane that is essentially the glue between all of your different infrastructure, right? Things were built out the way they were built out for a reason. Generally, at least hopefully semi-intelligent. So you had NAS systems that are serving a purpose. You have, a parallel file system that serves a purpose. But you need to be able to bridge those technologies with some kind of glue that holds all of that together and is able to dynamically allocate the data to make sure, right, you're getting that performance that Ryan was talking about, but still taking advantage of that infrastructure that's already in place for really good business purpose. And so that's exactly where Hammerspace comes in, right? We've got the capabilities like tier 0, where we are a parallel file system. So you are going to get that low latency, high performance, but also all along with it is those data management capabilities that are the glue, that are the data plane, that make sure that the data is also getting to that high performance storage when it needs to. And then if it's no longer needed there, is not consuming that expensive tier.
So, I mean, orchestration is a very common term in structured data, but less so in unstructured data. We talk about tiering, but what we're really doing is automating orchestration of data to whether you're placing it in the local NVMe across a GPU cluster, whether it's in the cloud or on-prem, or into other higher performance storage, or simply moving it out of an archive or consolidating it. So, Ryan, talk a little bit about that.
Yeah, I mean, that's really what we think could be the end goal to maximize that time per token. Is right now we're talking about unstructured data. For an agent or an LLM to use it, it still needs to be vectorized. That takes time, that takes GPUs, and that's going to slow down that total time per token. What if, when new files were created in that knowledge base example, they were instantly put in a vector database, and now your agent can just talk to the vector database, and you're increasing the output and the throughput. But that takes orchestration. And that's really what our recent announcement of our Hammerspace AIDP solution comes in, integrated in with NVIDIA's blueprints. It not only provides that global namespace and the objectives and the tier 0 that we've been talking about, but now by tying into the NEMO and the NEMO retrievers, it is pushing that data automatically into a vector database. So when that LLM or that agent comes in, it doesn't look for a file, right? It doesn't look for that unstructured data. It talks to the vector database already. So the time to token gets decreased even faster because it doesn't have to vectorize it. It's ready to go within that database to access on that live data.
But you jumped over an important point, and that is the management piece of this, because, right, it's not just all the data gets dumped in and vectorized, but you're curating only, and that's again where our rich metadata and objectives come in, right? So
Correct.
You're only vectorizing the parts you want as opposed to having to do the whole kit and caboodle.
Yeah,
and I think it's important.
I got excited about it. I skipped it. Yeah, go ahead.
Yeah, it's important to really emphasize, right, the objectives and orchestration, because historically, the word tiering was, it was a bad word in storage, because that equaled slow and non-responsive and manual process. And we've removed all of those challenges, right? So that things can be proactively in place, so that they are ready for high performance, low latency access when it's needed, rather than, having to call up somebody and say, hey, I need to go get stuff off of the cloud to bring it into the data center. That actually just happens for the end user transparently. And, tools like HSM tools have been around for forever and ever, but they didn't have that automation that we bring to the environment, so that, things are ready when they're needed, rather than having to take multiple steps and introducing additional latency, which, right, again, historically could have been days if you can't get a hold of the right person to re-elevate the data to the right layer. Now that's happening in the background transparently and as needed.
Yeah, I think that's really a key point, is that the transparency, because again, we're talking about enterprises that have day-to-day business operations with that same data on that same storage in place. And so it's giving exposure to a net new workflow without having to build a net new infrastructure, right?
100%, right? And that's the thing, right? Everybody, the models are changing daily. You can get a new model from some provider every single day, whether it's your Fables or your Sonnets or whatever your model of choice is. But in order to make those effective, doesn't mean you have to redeploy everything in your data center. You can use existing SAN devices. You can use existing NAS devices. You can use old NVMe hardware that might be just sitting vacant in a server that you have. You don't have to reinvent your entire layout to take advantage of the capabilities of those models. You just need the right tools and the right help to make it, because it's hard. Data orchestration is hard, but you don't need to be an expert and have a lot of manpower to make that happen if you have the right tools with you.
That's right. So if we kind of bring this together, I mean, we're really talking about an equation that goes across multiple things, where it's not just, okay, we got to get high performance storage, or it's not just we got to get access to GPUs, but it's really the operational side of this that we're talking about, right? So, what changes when an organization optimizes the entire journey instead of just one benchmark? How does that actually play out then for them?
I think, the key is that it unlocks just multiple dimensions of value, right? So not just addressing the operational piece, right? We're not just lowering cost. Yes, that is a key aspect of this, but by having the flexibility of, applying new models to the data, as well as, this real-time access to the entire data estate, right, will allow customers to get these new insights that they're striving for, and actually be able to drive applications that produce positive revenue opportunities, not just save money on operations, right? So it is a multiplicative aspect there, multidimensional, to not just reducing the cost of the token, right? That is, of course, essential, but I think you want to also realize that by doing that, you're maximizing your resources, but creating new opportunities for value within the company as well.
So Ryan, I mean, if you look in the trade press, you see over and over and over again talking about faster this, faster that. Again, and we've talked about that a little bit, but it's really production readiness must be continuous, right? Across live data and a live multi-siloed environment. That's a reality. So, go for it.
Yeah, to follow on Kurt's point, garbage in, garbage out. If you are trying to find some business value based in using LLMs or agentic workflows to provide that business value, if you're not providing the right information at the right time in the right place for that, you're not gonna get the results that you're looking for. People will be disappointed, and you're not gonna find the value for your business, whether it's internal, customer facing, whatever it happens to be. So how can we make sure that we can get there as fast as possible? That means no new hardware, and keep those GPUs fed with the right data at the right time. And that's really where some of our tools within Hammerspace can come in.
Which means,
and that allows us to, address what I think is sometimes a conflict within organizations. Was just reading some Gartner analysis the other day about the fact that the C-level, the C-suite, is expecting revenue generation from AI. But if you look at a vast majority of organizations, what are they doing? They're using it to control costs today. It's not generating new opportunities. And a lot of that, controlling costs comes from making it more efficient, and then thereby making your operations more efficient. But unless you can open the aperture to the rest of the organization's data, you're really not going to be able to fulfill that ultimate promise, which is creating new opportunities from all this data that you already have today.
In other words, enterprises are not investing in AI to generate tokens. They're really investing in AI. I mean, they may be investing it because they feel they have to, but ultimately what succeeds is if it actually solves problems and adds value, right?
That's exactly right. And I think, this is probably a topic for a later date, but the number of tokens you can produce, great, right? We want to reduce that cost. We want to reduce that time. But then you also have to look at the utility of each token you've generated. And again, if you're not using the entire data estate, then you're just limiting the value of every token that's being produced. And as Ryan had said, garbage in, garbage out. So if you don't have the right data or the appropriate data for your data set, then whatever you produce is not going to be of utility for the organization.
That's right. So, I mean, in this conversation, we've covered, that really an AI journey, right? So the 3 clocks, these are just ways of describing what is a journey from pilot to initial production to additional pipelines and additional use cases that is really aimed at, and a lot of times people are trying to figure out where it's aimed, but the ultimate goal is bringing value to the business, whether it's doing more, being ahead of the competition, making your environment more productive. This is a topic that we at Hammerspace talk about all the time. And we will, before I do that though, Ryan, Kurt, just give me a little bit of closing thoughts on where you think the next steps really should be and how organizations should be thinking about this. Maybe it's a little bit of what we've already said.
Yeah, from my experience, go look at any past POCs that stalled or failed. Why did they fail? Was it hardware? Was it, infrastructure? Or was it a person? Or was it just, you couldn't get the right data when you needed to, right? And really investigate, is that a true blocker in my infrastructure, in my organization, to really derive the maximum value of the tokens that I want to generate for my particular business? So first step I would do is look back at any failed or stalled or struggling engagements, say, is data the number one problem here? And I just don't even know about it. And if it is, what is the problem? Is it finding it? Is it orchestrating it? Is it putting it in the right place? Or is it all of the above? And see if that would address the issues.
Yeah, to follow on that, right? I think there just needs to be a fundamental shift in how we think about this challenge, that no, it's not an infrastructure challenge anymore. Right? It really is a data challenge. How do you make sure the data is available where it needs to be, when it needs to be? Yes, you need to have the right resources available in the first place, but the resources are not going to be leverageable unless you have that key data piece solved as well. And that doesn't mean, right, hey, I need to go acquire a bunch of new storage resources. Right? Figure out how to intelligently approach this challenge and implement something that has the automation and also the flexibility, like Hammerspace, to be able to help bring that connectivity into the environment that's lacking today.
That's good. So thank you, both of you, for your comments here today. And I'd invite everybody to, we've got upcoming webinars. We have a lot of content that is continually going on this. In fact, today there's a blog post that's going out on this topic, the 3 clocks. And then next week, we're going to have a follow on that on operational AI entitled "The Cost of AI Isn't What You Think." These dive a little bit deeper into this. And then as you can see on the screen, please tune in to the next week to the web on modernizing HPC and AI. And this is with us and with Karasoft and with Cisco. And then we have additional content that is continually out. So thank you very much for your attendance. This will be posted. This recording will be posted. Anybody wants to follow up. And thank you very much and have a good day.
Thanks, Floyd.
Thanks, Floyd. Thanks, everybody.